notes for today, we are going to start talking about functions, okay? So we have done a little bit with functions. The IXL that you did for me yesterday was evaluating functions. So you guys had things like they would give you f of x equals x plus 3 squared, and then they might ask you to find f of 5, right? So yesterday at the end of class, we played my What's My Rule game, right? And so those and I got to grade those. I forgot those. We'll do that today. But all right, Julie, put your computer up. So the What's My Rule game that we're doing here, that we did, was I had a function rule. So my rule might be x plus 3 squared. And so if you gave me a number, I would take that number, I would add 3, and then I would square it, right? So a function rule tells us what you're doing to a number if you're given that number. There are lots and lots and lots of different ways that functions can be presented. Okay, so we're going to start from the most basic types to the more complex is what we're going to do here today. So the first type, this is actually not a function, but the first thing we're going to talk about is a relation. A relation in math is a set, let me change the blue so that shows up, so you see what I'm writing. A set of ordered pairs. So, ordered pairs, you've done since probably 6th or 7th grade. Ordered pairs are just coordinates that we could graph on the coordinate plane, right? So it's an x, y coordinate. So if I have this particular example, I've got the ages of students and the grade that they're in. I could write them as ordered pairs, and I would just write it like this, 6, comma, 1, I'd use parentheses around it. Ordered pairs would put parentheses around. So if I wanted to go graph that, I would go over 6, up 1, I would graph that point. You guys remember doing that from earlier. You know how to graph a point, right? So I would also have 12, 7, 15, 9, 15, 10, and 18, 12. So you can't see. Okay? All right, so that would be our set of ordered pairs. This is a relation, okay? Each number relates to another number. So being age 6 relates to being in the 1st grade. Being age 12 relates to being in the 7th grade. So this is a relation. The domain of a function is your possible x values. So when we are given a relation like we are given here, for our domain, we're just going to list the x values. Okay? And when we do, it is usually written with the squiggly brackets. Sometimes you'll see it like this, x such that x equals 6, because that's x value, 12, 15. You have another 15, but you're not going to list it twice. You only list it one time, and then 18. Okay? Now, this part right here, this is just notation that you sometimes see. Other times, you may just see it in squiggly brackets. It may just look like this, 6, 12, 15, 18. So I just wanted to throw that notation out there in case you do see it like on a multiple choice question or something. You'll be familiar with it. You don't necessarily have to write it for me every time. Okay, and when writing the domain, do not list values twice. So you guys have already seen this because I had 6, 12, 15, 15, and 18. But I just listed 6, 12, 15, and 18. I didn't list that 15 twice. Okay. Our range, what do you think range is going to be? It is our possible Y values. And so, for Y values, for the last example, for my ages and grades, you might see it written like this. Y, that line right there means such that Y equals, and you just list your Y coordinates. 1, 7, 9, 10, 12. Or, a lot of times you won't see this notation here. I don't care if you write it or not. Write it if you want to. Don't. It's fine. I just want you to be familiar with it so you know, if you see it, what it means. 1, 7, 9, 10, 12. So you could write either one there. Right.
So it's like is that how it goes? It's like in order?
They don't necessarily have to be in order. Typically, like on multiple choice, you're going to see them written from lowest to highest, but they don't have to be in order. If I wanted to list 12, 9, 10, 7, 1, if I want to put them out of order, that's fine. It's just listing all of your Y coordinates there. When you're writing the range, again, do not list values twice. There weren't any values listed twice for my range for this example, but if they were, I would only list them one time. Okay, so relations can just be any set of ordered pairs. But functions are a specific type of relation. Okay? So a function, which we see down here, is going to be a relation where each x value has only one y value. And we'll talk about what that looks like here in a second. So, for example, yesterday, when you guys were giving me numbers for my rule, you were giving me the x value. So you gave me a 6. I told you that it was a 10, right? So you were giving me the x value. I was giving you the y value that went with it. So did you ever say 6 and I said 10 and negative 14? I did not do that, right? I only gave you one number back. So those rules that I were giving you were function rules because each x only had one y that went with it. Okay? Now, it was possible that, let's say that my rule was x squared. I did do that rule, right? So if you told me -1, what would I, if my rule was x squared, and you tell me -1, what would I give you as my y value? So my rule is x squared. I'm going to square it. So you tell me -1, what do I tell you? Not -1. What is -1 squared? It is 1, right? So when you plug in, when you give me the x value of -1, I told you 1. What about if you tell me 1? Oh, I ran off the screen.
Wait, what?
So, right over here. If you tell me -1, I give you 1. What if I'm using the same rule and you tell me 1? I just give you 1, right? So the y values might repeat themselves. I might tell you the same number sometimes. But the numbers you're giving me only have one answer that go with it. Okay? So basically, there are several ways we can think about this. Okay? One thing we can do with this is we can make what we call a mapping diagram. So the diagrams, I'm going to go ahead and put it right here. The diagrams that we just made are called, we haven't made them yet, but I'm going to skip down here. They're called mapping diagrams. Please make sure you're writing all this down. So some of you have not picked up a pencil. Okay, so if we're given a list of ordered pairs like we're given here. So I've got 3, 4, 2, 6, -1, 2, and 4, 6. So I would list my domain in the first oval that I have here. So domain is x values, 3, 2, -1, and 4. So 3, 2, -1, and 4. Don't worry about them being in order, just list them. Okay, you can put them in order if you want, but I'm just going to list them. And then you're going to list your range values. So you got 4, 6, 2. You got 6, but we're not going to list it twice because when we write range, we don't list numbers twice or domain. So 4, 6, 2. So once you have made this mapping diagram, you're going to take each point. 3 goes with 4, so I'm going to draw an arrow. 3 goes to 4. 2 goes to 6. -1 goes to 2. 4 also goes to 6. So, each x value only has one y value that goes with it. Even though this y value over here does have two x values, right? So from each one of these x values, I only see one line going out, right? So this would be a yes. This is a function. Okay? So it is a function if each x, which is your domain, each one over here on the left, only has one arrow that goes out from it. Okay, so 3 only has one arrow, 2 only has one arrow, -1 only has one arrow, 4 only has one arrow. Okay? It is okay that 6 has two arrows over here. We don't care. We only care about domain. Right? So this would be a function. Okay? So if we do the same thing for example 2, I would list my domain. I've got -10, -5, -10. Oh, wait. Should I do that?
No, you can't.
Don't list it twice. It's already on there. If you do, it'll look like a function even though it's not. And -15. So I'm listing all of my x values. Don't list them twice like I tried to do there. Then I list my range. So I've got 100, 20, 0, and 200. And I'm going to draw an arrow for each pair that goes together. So negative 10, what's it go with? 100, because I've got the point negative 10, 100. What's negative 5 go with? 20. What's negative 15 go with? It goes with 200. And then I also have this other negative 10 right here. So negative 10 went with 100, but what else did negative 10 go with? 0. So, do any of our domains, any of the numbers in our domain have more than one y? Yes, it's this 10 right here, right? That 10 goes with a 100 and a 0. So that would be like yesterday in my rule, if you had said negative 10 and I said 0 and 100. Right? I didn't do that any because I was using function rules. So this one would be a no. This one is not a function. So if you have a x value that has two y values, it is not a function. Another way we can think about this, when we're looking at that domain, what could you tell me just looking at that list without even making the chart? What could you tell me about that list that lets me know, hey, this is not going to be a function? Okay, an x value is repeated, right? So you might want to make yourself a little note of that over here somewhere. If an x value is repeated, the relation is not a function. All right, so I'm going to pull up Desmos real quick, and I want to look at this look at that particular function on the graph. All right, so okay, so my points are negative 10, 100, negative 5, 20, negative 10, 0, and negative 15, 200. Nothing's showing up. How come? Not because it's not a function. Why can't I see any of these points?
They're negative.
I do have some negatives. What? Look at that first point. Negative 10, 100. Is that going to show up on this graph I've got right here?
Oh.
I only go from like negative 10 to 10 on this graph, right? So I need to change that. If you're using Desmos, because we're going to use Desmos some in class, you get to use Desmos on your final exam. It will be on the final exam on the calculator active questions anyway. Some questions will be, yeah, it'll be on there too. So if you hit this little wrench right here, I need my x's to go up to at least 200, right? And my y's. So my y coordinate goes up to 200. And then I can kind of zoom out a little bit. There are my points, right? So notice what is happening here. Let me make this where it shows. Oh, there we go. That looks better. All right, so when I graph these points, my problem with this was this negative 10, 100 and the negative 10, 0. So on the graph, which 2 points are those? What colors? Red and green. What do you notice about red and green? Same line. Same vertical line, right? Because if points have the same x coordinates, they're going to be on that same vertical line, right?
X going this way though? Is there X going that way?
Vertical lines, which we hadn't talked about this really, but vertical lines are going to be x equals a number, but the y-axis is vertical, so that's why it seems backwards, right? But if they have the same x coordinate, because see, when you graph this green point, you go -10 for your x coordinate, you go up 0, right? So the x coordinate is -10 here. When you graph that red point, you go -10, which gets you on the same vertical line, and then you go up 100, which graphs this point. So they end up on that same vertical line. So if the x's are the same, you're going to be on the same vertical line. If the y's are the same, you'd be on the same horizontal line. But we won't get into that really today. But if the x coordinates are the same, you're going to be on the same vertical line. So there is a really convenient test that we can use that will let us know if a function or a relation is a function or not if we have its graph. Okay? So it is called the vertical line test. So the vertical line test tells us if a vertical line passes through two or more points, the relation is not a function. So, vertical line test is very simple. We've got 3, 0. I'm going to graph all these points. You graph them too. Pastor, make sure you're graphing these. -2, 1, 0, -1, -3, 2, and 3, 2. Now, a lot of times if we're going to use vertical line test, we'll already have it graphed for us. So graph all 5 of those points. And so I'm going to take this vertical line right here. Let me make it green. Let me make it bigger. All right, so I've got this vertical line right here. You can think of taking your pencil, straight line, except for Wade, who probably doesn't have one. You got 2 today. You can take your pencil, that's a straight line. You can take, sometimes I used to do this where I'd have like a stick of spaghetti. That's a good vertical line test, right? So if you take a vertical line and you go through this graph, like here I only touch 1 point. 1 point. 1 point. Uh-oh. Right here, 2 points. So when I cross 2 points, that tells me this is not a function. So is this relation a function? This one would be in that.
Okay, so basically, if you have like 2 on the same thing, it's a non-function.
Right, same vertical line.
Like vertical.
Yeah.
Okay.
Yeah. And we can, how else could we tell just by looking at the relation here, the list of coordinates? So we had that 3, 0 and 3, 2. That x coordinate 3 right there was repeated twice.
Oh, okay.
So if the x is repeated, it's not a function. Okay? So it depends on what you're looking at. You don't necessarily have to graph this to tell it. But you could graph it. Okay? So, you guys don't have this printed. I did put it on, Canvas so you could see it later if you want to look at it. Let me zoom out just a little bit. So I want you just like over to the side or down there at the bottom. I just want you to number 1, 2, 3, 4 and put a yes or no for each one. Yes or no for function. You don't have this. Wherever you want, just down at the bottom or somewhere. This is not, you don't have this in your notes because it was already like 6 pages long. I didn't want to print off everything here. I want you to look at that. Just number it 1, 2, 3, 4. Tell me yes or no for each one. Are these functions? So when you see like a solid line, that is a bunch of points all right next to each other. Right? So. Why is this showing up so light? Okay, there we go. Alright. Okay, everybody's decided on 1 through 4? You have yes or no written down? Let me see yes or no written down for 1 through 4. Yes, it is a function, or no, it is not a function. All 4 of them. You get different answers for all 4. So like 1, you would say, yes, it is a function. No, it is not a function. You're going to use that vertical line test. So here I will move my vertical line here. All right. Okay. So, Alyssa, what do you think for number 1? Yes or no? It is yes. It is a function. Because there's nowhere where this line is going to touch the graph twice. Right? 1 point every place. Just 1 point. Nowhere that it touches it twice. Some of it, yeah. Number 2.
No.
Okay?
Wait, it's yes, my fault.
All right, so is there anywhere that you touch this vertical line twice? No, it gets really steep over here where it kind of looks like maybe it touches twice, but it does not. It's still like moving out just a little bit. So if it touches that vertical line twice, it's a no. But this one is a yes because it does not touch that vertical line. Tell what? It will very clearly be perfectly on grid lines. Like, it'll be perfectly straight. And let's see how you can tell right here it is not parallel to this vertical grid line right here. Right? So it is, you can tell that's getting a little closer and closer and closer and closer to that vertical grid line there. So if it has any slant to it at all, then you're going to say that it is a function. Okay? So that's a yes. Let's see, Easton, what do you think for number 3? It is a function. You are correct. This one's a yes. So 1, 2, and 3 should all be yeses. All right, Julian, what do you think about 4? That's a no because pretty much everywhere it's touching twice, right? Except for at like this very beginning point where you just have 1 point. It's touching twice, so this is a no. Okay? All right, here are 5 and 6. 6 is a little tough to do. 5 should be easy, so I'm just going to go ahead and call on you on that one. Jada, what do you think? A yes or a no? That one's a no. because clearly, pretty much everywhere, it's touching a vertical line twice. 6 is a little tough to see, so I'm going to pass the vertical line on each point for you. Oh, right here on that second line, that is a no, because you touch at 2 points right there.
Other than 6?
Number 6, yeah. I just scrolled down.
Oh.
Yeah, there's even more. So 5 is no, 6 is no. There's more. There's 12. All right, so let me scroll down here some so you can see the next 4, 7, 8, 9, and 10.
Oh.
Okay, 7 has a lot of points, so it's going to be hard to see from where you're at. So I'm going to just move the line for you.
Yeah, that's a yes.
Let's see, let me move it. Let's see. Here we go, there it goes.
All right. Yeah, there's one. Okay, y'all quit. Which one is it?
Keep watching. I think it's good so far, right?
Yes.
It's hard to see from where you're at, I know. That's why I'm doing this for you.
Yes.
Right there. Those are together.
It is a yes. There are not any points that are directly over top of each other. It's probably a little hard to see from your seats, but that is a yes.
I mean, I thought it was yes.
So 7 is yes. Do 8, 9, and 10 on your own, real quick. Okay, jot down. They do touch right there. It doesn't quite look like it, but they do. Even though it doesn't really matter if they touch or not to answer this question.
So
There's two
basically,
more.
if they're touching or over each other, yes.
All right, 11 and 12. Answer those real quick, and then we'll go over these. All right, 11 and 12. All right, so Caroline, what do you think for number 8? It is a yes. 9 is a no. 10 is a yes. 11 is yes. It's a very big no, right? Okay, so does vertical line test make sense for this? Okay, so we can tell if something is a function by that vertical line test.
I get this vertical.
Kind of.
Well, I don't get the rest.
Yeah.
All right, so one thing that you can always do, if it is, so if you have like that first example that we did, if you graph each point, you can see if it passes the vertical line test. Or if you're looking at the coordinates of the point, if you see 3, 0, and then you see 3, 2, they have the same x coordinate. When you go to graph them, 3, 0 is right here, 3, 2 is going to be on top of it. They have the same x coordinates, so they're going to be on the same vertical line. So if you see those x coordinates repeated, then that is not going to be a function. So that can help you there too. Okay, so let me look at your Excel real quick. I might break off here and pick back up tomorrow.
It's like what?
I think we've done.
It is 11 to 6.
All right, so I said Q2 and Q4, I think. I think. If you get a problem like this on your Excel and it gives you a graph and asks you for domain and range, what should you do first? Look at all, guys, sit down and listen to me. You're all going to have questions here in a minute. So when you're doing your iExcel, if you're given a graph, right, and it's asking for domain and range, you can write the coordinates of each one of these points, right? So we can, or at least think of them, like this point right here is -4, -4, -1, -4, 5, 0, 4, and 2, -1. So you can list the coordinates of each one of those points and then pull your domain and range from that. Okay? And that's the types of problems you'll see. Some of them will already be listed out coordinates. Some of them you'll have to pull it from the graph. Then you will also see on that second part for Q4, you're going to look at the table and identify if it is a function or not. Is this a function? Let me zoom in a little here. Okay, it's not. How do I know? The zeros, the X's are repeated, so that's a no. All right, this one. That's a yes. All the X's only have one Y. And then so on. So everybody right now needs to get out their computer, and you're going to work on this. We've got 10 minutes, so you're going to work on it right now. He sat back there and did it while we were doing it early because he does everything early because he just does.
I think we should